Okay, I'm looking to verify the functionality of the universal robot as follows. So what I have here is a couple of pieces. Call this the good bone, and then this would be the bad bone. And so this is the bad bone that would be, broken, and it could be tilted a variety of different ways. And the goal would be get the broken bone set back equal to the new bone. Okay, and so a couple of things here. What I have right here is the good bone is a user frame. And this user frame could be taught using the 3-point method, origin, X, and then Y, and you would create the user frame here. What we're hoping to do is to bring in a sensor that, when oriented correctly, will teach this frame right here, but it would teach it using like the 6-point method, which would give us X, Y, pitch, roll, yaw. Okay? Now, the bad bone here is also going to have its own user frame, but the bad bone might be maybe shifted like this, okay? It might be broken. And so the bad bone is going to need, you could teach this using the 3-point method, where the origin's there, the X is here, and the Y is here, but our sensor is automatically going to teach that frame for us, X, Y, Z, pitch, roll, yaw, okay? And so what I mean by that is that the functionality that I'm talking about is if I go and I look at what a position register is here, and I call one here that is good, and I go to look at the position of this, you'll see that this position register has data, positional data, X, Y, Z, and then there's your degree of rotation. I can go in here, right here, and I can manually change this to any number that I want, any of these numbers. But what is going to happen here is our sensor, the location of our sensor, is going to bring these numbers in to teach the first user frame and then the second user frame. We're also going to need a third position that is taught, and that is going to be this up here where the robot grabs a hold of this part, and that is going to be another position register, okay? And so what we're going to have is 3 position registers. This one up here is taught. These ones are brought in by our sensors, and the thing is, it doesn't matter. These can be rotated on the table wherever you want, as long as they're read in there and that one point is taught, okay? And then so when you go to your program, the first thing that you're going to do is you're going to take your user frame and you're going to set it equal to your position register. So the position register that the sensor read, those 6 numbers, are automatically written in to create this user frame, and then it will come in and it will read this user frame, and then we've got the third user frame. So all we're going to do is we're going to subtract, and the robot will do this, subtract these numbers from these numbers right here, and then we will apply the difference to here. So in this case, assuming these were on the same plane, it would subtract the 2, and then it would do the translation. It would move in the X direction and in the Y direction to bring it in line. If for some reason these items had some rotation on them and it was cockeyed, well, then I imagine that it would probably do the rotation first to bring this and then rotate it, and then it would do the translation based on that subtraction to bring those in line. So I'm just want to verify that through variables on the UR, I am able to do the same thing that I showed right here, where I can go and get hard access to this positional register data, bring it in, and modify it as much as I want, subtract it, multiply it, compare it, and let the robotics kinematics package solve all the frames relative to each other. Give me a call if that doesn't make sense.